This is the first video tutorial on using Glowscript for Physics 151 simulations. This will start very gently, basically illustrating Newton's first law. If something is not moving, it tends to stay not moving. So we're not quite to simulating moving things just yet, but we'll get there. I will open up a new browser window here. The environment we will use for the programming is called trinket.io. Trinket.io. If you do not have an account yet, you can still sign up or sign in. There's a sign up here. You can create an account simply within Trinket, or you can log in through one of these other three ways, for instance, through Google. For simplicity, I've just been signing in with Google. So you can pause if you need to right now to create an account or to sign in with Google. Signing in with Google. So when you first come in, if you haven't done anything in Trinket, your window will look pretty much like this. If this is your first time coming in, you may not see this new Trinket blue box. In that case, you can click on the Home button, and it will bring you here. So Trinket is the environment. It is web-based. You don't have to worry about installing a programming language on your computer. So you can get to your programs from anywhere. So to get started, we will click on New Trinket. Now, the language we're using is called Glowscript. Glowscript is a newer version of something that was called VPython. Python is a fairly standard language. VPython added modules that let you make three-dimensional pictures, animations. And since then, that has been updated to become Glowscript. So we will work with Glowscript in this class rather than Python itself, because we will want to see the pretty three-dimensional pictures. I do not want to change my color scheme. Click on Glowscript. Now there are two ways you can go about doing the programming. We will use the more traditional way of actually typing lines in. So we will click on Python here. And you'll see it is ready to go. It gives you the first line, Glowscript 2.7 VPython. That's there so that Trinket knows which language you're using. I like to hit enter to put a blank line. Blank lines tend to make programs a little more readable. This is also a good time to go ahead and give your program a name and save it. You should save frequently, because if you don't, you could find that you've lost a lot of work that you've done. So if you go up here where there's a little house and it says My Trinkets, and then in red it says Untitled, click on Untitled and you can give it a name. First 151 Glowscript, and click on Save. Now every time you click on Save, it will automatically save it with this name. So it has saved it. It moved the cursor back to the beginning, so I need to click on line 3 and put the cursor back where I'm going to start typing. I'm going to zoom the browser in a little. to make it easier for you to see what I'm typing. So, the Glowscript program will do two things. It'll let us do calculations of objects, moving objects, objects that are interacting with each other, and get numbers for the motion. And it would also let us see an animated picture of that motion. So first we're going to make a picture that shows a sphere. Then we will talk about how to work with that sphere and do things, change the properties of the sphere, such as where it is. Then later we will see how to actually make the sphere appear to move on the screen. So Glowscript has the ability to create pictures of objects. If you want to make a sphere, you start by typing sphere. Then, to be able to give properties to the sphere, you type in open parentheses. Glowscript does one thing that can be useful, and that is when you type in open parentheses, it automatically closes the parentheses at the other side and leaves a cursor in between. So what I type now will be between the two parentheses. What are the properties of a sphere? Well, a sphere has a radius. So radius. This is a built-in property of a sphere in Glowscript. In computers, when you want to set something that has a name, such as the radius property of this sphere, you put the name of that thing on the left side of an equal sign. So the left side of an equal sign means this is a place in memory, the place in memory that is named radius of this sphere, and the right side of the equal sign will be what number or what other information do I want to put in that place. And I will pick a radius of, say, 0.2. When you're giving properties in this sort of situation within the sphere, to do another property, I can type a comma. Now it will let me do another property up. Another property would be the position of the sphere. Where is the position of the center of the sphere? Position is abbreviated POS, pose. Pose for position. So again, I am taking the place somewhere in the internet that is labeled the position of this sphere for my program. The equal sign meaning that what I type now will be placed in that position of computer memory. And let's give it three numbers. 1, 2, -3. X equals 1, y equals 2, z equals -3. Save often. And it's worth running the program to see what happens. So run is this little play button up here. Click on it. Over here is where things will display. It looks black. There is no sphere. I scroll down. Because I've zoomed in, I have to scroll down. It says property pose must be a vector. One nice thing about Glowscript is it has built in the ability to recognize and work with vectors properly, do vector mathematics automatically. But to do that, you have to tell Glowscript that you are in fact working with a vector and not just a group of three numbers. So pose has to be a vector. So we can't just say pose equals 1, 2, -3, a triplet of numbers. I have to put the cursor in front of that triplet of numbers. I need the parentheses here, but I need to type something that tells Glowscript that this pose, this position, is actually a vector. And Glowscript uses the shorthand VEC for vector. So now I have set the position, which is a vector, the position vector of the center of the sphere, to be the vector with x component 1, y component 2, z component -3. That will put the position of the center of the sphere at the location x equals 1, y equals 2, z equals -3. Save often, and run it to see what happens. And look, there's the sphere. It's white because I did not tell Glowscript otherwise. If I hold down the right mouse button and move the mouse around, I can rotate my field of view. This is actually a three-dimensional field of view. So as I rotate the field of view, I'm getting closer and further away from the sphere, and its apparent position in the window changes because I'm rotating where I am. If I hold down both mouse buttons, move up, I zoom in, move out, I zoom out. So you have the ability to control how you're looking at the scene here and to zoom in and out. Okay, I'll run it again to get back to the original picture. So another property that you can give a sphere, it doesn't have to be white. So I want to go back to the sphere, click just inside that last parentheses, type a comma so I can do another property of the sphere, and I want to set the property named color. So color equals sign, so whatever I type next will be put into the place named color. To do colors in Glowscript, you can do it a couple of different ways. If you want to see the possible colors, I'm going to open a new tab here for a second. Type Glowscript color, and there is extensive online help to help you with anything on Glowscript. So I will just click on this first result here, and this tells me different ways of doing colors. If you want to define your own color, you can use what's called the RGB. It will do various mixes of red, green, and blue. But if you just want to use colors that are preset, you can use any of these colors here. Generally, the basic primary colors, red, yellow, orange, well, that's not quite primary, cyan, and so forth. So anytime you need help with Glowscript, and then what you need help with, and you will find some help. So I like green. So the way to use a pre-assigned color is you type the word color again. That gives you access to the list of colors. Then a dot to pick out a particular color, and then the particular predefined color you want, green. Save often. Run to see how it's looking. And it looks the same way it did before, but now it's green. Okay, very good. Now we can do some other things once we have this sphere. For instance, if we want to, we can print out certain aspects of the sphere. We can do that just to check to see what they are if we have written a program that tends to change things. So for instance, if I want to actually see a print out of what the position of the sphere is, I can put my cursor at the end of line 3, hit enter to start a new line. And to actually print out what something is, you type print. The magenta color here says that Glowscript recognizes print as a basic built-in function. Open parentheses. It also supplies a close parentheses. And inside the parentheses, I can give the name of whatever it is I want to print out. So in this case, I want to print out the position of the sphere. So this is a property of the sphere. So I type sphere. It's a particular property of the sphere, so I type a period. That will now give me a particular property of the sphere. Then I type pose, P-O-S. So sphere.pose, again, is a particular place in the memory of some computer somewhere. And I am telling Glowscript to print out whatever is located in that piece of memory. Save. Run. And I'll have to scroll down since I've zoomed in. And it says undefined. The reason is that sphere is an object, but to do what I'm trying to do, I have to give that object a name so it knows what I'm talking about. So I have to make two changes here. First, I'll go to the beginning of line 3, And with the cursor at the beginning of line 3, now I can give this sphere a name. In other words, give a name to the place in memory where all of this is, and I need to do that to be able to get to it. Okay, so it's a little roundabout, but the reason for this is there could be a lot of spheres. I could have made other spheres, and if I just say sphere, it doesn't know what I'm talking about. So I will give this sphere a particular name. Ball 1 equals. So now there will be a location whose name is ball 1, and that location will contain all the information about this sphere, this object, this sphere. Second change is now I have to talk about the particular sphere whose position I want to print out. So I can't just say sphere, I have to say ball 1.pos. So now that is the name of the position of the sphere whose name is ball 1. Save it, run it, and you will see here it obligingly prints out, using the notation in your book, the vector whose components are 1, 2, and -3. It's not a coincidence that they use the notation in your book, because the people who wrote your book actually created VPython and Glowscript. Now you'll notice that the program did not print out something that I tell you you should always have when you write a number, and that is the units. Glowscript in and of itself does not know what the units are for these numbers. So when we set the position vector to be 1, 2, and -3, Glowscript just thinks of those as numbers. You have to supply in your own mind what units you are working with. Okay, so I'm going to move this over a little. I'm going to go to the end of line 3, type a couple of spaces, and then a hashtag or a number sign or a pound sign. And you'll see that is green. That is a way of telling Glowscript that you are now going to write a comment, something that clarifies or explains what you are doing. Now I'm going to clarify that my units are in meters. So now somebody reading your program knows that when they see these position vectors and this radius, that the units involved are in meters. Glowscript doesn't know that. So for the printout of my position vector, it would be nice to specify that also. So I can put the cursor inside of the print statement, right before where it says ball1.pos, and you can tell it to print a little bit of text that goes with the number you're printing out. So to print text, you do a quotation mark, ball1 position, close quotation, and then a comma. So it's going to print out the text ball1 position, then it will print out the vector it printed out before. Now I can put the cursor here just inside the parentheses to another comma, so I can put in some more text and specify meters. And you'll notice in this case, when I typed the first quotation, it also supplied the second quotation mark. So within the quotation marks is text that'll be printed. What is not in quotation marks is the name of a location in memory somewhere, and it will print what is in that location. Save, run, and now it prints things out in a very nice way. It tells me what I'm printing out, the ball position, and it also specifies the units. So remember, we talked about in class that these three numbers, the components of the vector, the 1 meter, 2 meter, and -3 meters, that is the component method, in a sense the mathematical method of representing the position vector. Another way of representing a position vector is to draw an arrow that goes from the origin to the location of the object. So we can also do that in Glowscript. So I'll put my cursor at the end of line 4, hit enter a couple of times. And now I want to make an arrow that represents this position vector, whose components are 1, 2, and -3. Okay, so I will type a hashtag and then show arrow to represent position vector. And I haven't actually entered any thing that runs a program, so it doesn't give me a chance. Oh, there's the save. I'll run it. I have not added any code, so it'll stay the same. If you have not done so, you should go ahead and pause this and go ahead and type in what is here in your own Trinket account and then save it. We will be using it in class, and we will also be using it later as we start seeing how to simulate making things move and interact with each other. Okay, so now I'll represent the position vector, and again, after I type the next couple lines and see how they work, you should type them into your own program and make sure they work, and then save it. So click on line 7. Now I want to represent a position vector with an arrow. So I'll go ahead and give it a name, pose arrow. The capital A matters. It makes a difference whether letters are capital or not capital. So I use a capital A to help make it easier to read this. So this will be the position arrow, the arrow that represents the position vector. That's the name I'm giving to a particular arrow. So type equal, so I can start now typing in the properties of this particular arrow that represents the position vector. Well, to make an arrow, you type arrow, open parentheses, properties of the arrow. The most important property of an arrow that represents a position vector is the property that basically is the vector. It is the property that tells it which way to point and how far to point in that direction. And we type that in component form. So the word for that property, which is really the key to representing a vector by an arrow, that property is axis. So within an arrow, the axis property is the vector in component form that the arrow represents. So axis equals, and I want it to represent the position vector of ball 1. So instead of typing that vector's components in all over again, I will simply say ball1 dot pose, because again, that is the name of the position vector that represents the position, that is the position of ball 1. So the axis is the vector that I want to represent by the arrow. I will go ahead and save and run. There are other properties, but I will go ahead and run. And there it is. I'll rotate it a little so you can see it a little better. Now, there are a couple other properties that are useful. In this case, this arrow does in fact represent the position vector. Its tail is at the origin. How do we know that? Because if we don't tell Glowscript where the tail of the arrow is, then it puts the tail at the origin automatically. The axis tells you the actual arrow, the actual vector. Another property we could do is we may not want the tail of the arrow to be at the origin. In this case we do. But if we do want to specify where the tail is, I'll go inside the parentheses, type a comma, And the name for where the tail of an arrow goes is, again, pose, for position. In this case, I do want it in the origin, so I'll make the position. Again, position has to be a vector. Vec 0, 0, 0. So this locates the position of the tail of the arrow at position vector 0, 0, 0, which is the origin. Okay, this line's getting pretty long, so I'm going to add a couple more properties to the arrow, but I'll do it by first putting the cursor at the end of line 7 and hitting enter. And I'll assign some other properties by referring to them with the dot notation. So pose arrow is the name of the arrow. Dot color. This will now let me change the color property of this particular arrow. So equals color dot yellow. Another property I might want to change is how thick the arrow is. Pose arrow dot, and the name for this property is called shaft width. So now there is somewhere in memory a property of this arrow. Its name is pose arrow dot shaft width. To set that property, I type the equal sign, and let's set this property to be 0.05. And again, Glowscript doesn't know units, but intrinsically I'm going to assume everything's in meters. Hit enter again, save, run it to see how it looks. So now it's made the arrow a lot skinnier, so it doesn't look as cluttered, and it is, again, yellow. So I can rotate it around and zoom out a little to get a good look at things. So those are the key properties of the arrow, and this yellow arrow now represents the position vector of that ball. Now, something else we've done in class when dealing with position vectors is we've looked at ideas of what is the size of the position vector. In other words, how far are we, in this case, from the origin, and what is a direction. The direction we will discuss in class. Finding the size of the arrow, the distance, I will click on line 10, hit enter, and what we want is the magnitude of this vector, the size of the vector ball.pos. Now again, if you need help with something in Glowscript and you forgot how to do it, you can type Glowscript into the URL bar, and then in this case, vector magnitude. And it has a lot of different things here. I don't see the word magnitude. I don't want to watch someone's video. This one has there. Here's the word magnitude. And down here it says vector magnitude, S equals mag of C. So one way of getting the magnitude of a vector is to use what's called a function. Mag here is a function. C is the vector whose magnitude you want to find, and S is the magnitude. So I will give that a name. I will call it distance. Into this piece of memory that I'm labeling distance, I want to put the magnitude. The magnitude of what? The position vector of ball1 dot pos. And I won't know what that distance is unless I print it out. So print, open parentheses. Let's have some quotation marks. distance from origin is, move over, type a comma, so we'll print that text. I want to print that distance number, the number whose name is distance, another comma, and specify my units of meters. Save and run. So now it is printing out the distance from the origin. As an exercise, I will not have you turn this in, but as an exercise, you should be able to verify that that is in fact the correct distance, that this number 3.74166 meters is in fact the magnitude, the size of the position vector whose components are 1, 2, and -3. You should be able to confirm that. And you should, simply as a matter of good programming practice. When we do these programs, we will first use them in situations where we can do the calculation to check that everything's right. And then we can forge on and let the program do work for situations where the calculations are hard or tedious to do. I will show you one more thing, just so you can see what you can do with these pictures. I'm going to rotate the ball. And you can see the tip of the arrow is inside the ball, but we can't quite see it. So sometimes you might want to be able to see inside of the sphere to see the tip of the arrow that's inside of it. So I'll put the cursor at the end of line 12. And the property of that sphere, which I'm calling ball 1, the property of that sphere which tells you how transparent it is, ball 1 dot opacity. So if I set that to say 0.6, 0 would mean it's completely transparent, so 0.6 is kind of in the middle. So I'll set that to 0.6, save, and run it again. And now you'll see that the sphere is a little bit transparent, and you can see the tip of the arrow inside of it and see where that tip is. It is in fact at the center of the sphere. So again, this illustrates Newton's first law, because in the easy sense of velocity zero, because it says if something is at rest, it tends to stay at rest. This object is maintaining its position, its motion of not moving, because we haven't done anything to change the motion. And that will be down the line, not too far in the future. So you should make sure that you can type in what you've got and that it works for you. We will be starting with this in class. You will be modifying your program in class, so please bring a computer if you can. And to give you a heads up, we will be looking at how we can get the information about this position vector, not just its magnitude, the distance we found, but also getting its direction. What your book refers to as a unit vector or a position vector, whose components tell you something about the angles of the vector relative to the three axes. So we will work with that, set that up in class, and also verify the calculations by hand, that the calculations the computer are doing are correct. One last thing is, at some point I may ask you to send me a link to your program. And if you click on this icon here, which is not obvious to me, you have various things that you can do. And in this case, if you click on link, it creates a link that you can then send to me, and then I can look at your program. So if you are having trouble with your program, you can do this, send me the link, and I will look at it. There are strange things that can go wrong in Glowscript sometimes, and sometimes it's not obvious what is going wrong if things are not working. I have enough experience that it's a little quicker sometimes. I can sometimes see things that you wouldn't even notice. So if you're having trouble with something that's not working, you can copy this link and then email the link to me, and then I have direct access. I can look at your program. I can't change it, not within your account, but I can look at it and tell you what's going on. Very well, that is the end of this tutorial video.